Hello, my name is Hunter Collier, and this is my proposal on the effects of invasive hogs on the whitetail fawn survivorship in Texas. So for a bit of background, this proposal focuses on the nature of invasive hog populations in Texas and how it affects other organisms, particularly the white-tailed deer. I'm assuming we all know what invasive species is here, but it's basically a plant or animal that is not originally from this particular ecosystem. And this can cause a whole host of problems, some of the worst being extinction of the local species after they're forced to fight with the invasive species for resources or niche space and end up losing. So, in Texas and most of the southern North America, the growing hog populations have been cited for habitat destructions and many other issues. An area that is not heavily studied, however, is how these hogs affect specific organisms, and in this case, such as the white-tailed deer, which is a very common species to these areas. With this research, I hope to determine if the amount of white-tailed fawns that reach maturity in an area with no hogs is different to an area that has an abundance of hogs. And with that data, I hope to be able to imply a difference in survivorship of the fawns between the two locations. I feel that this type of research is important because it allows a look into the direct effects of species invasion on a particular local species. The data in this proposal seeks to act as a first step in understanding the interactions between these two species. Obviously, if a correlation between hog density and fawn survivorship is found, then other research could then be developed to determine the specifics of that correlation and possibly apply that to other species interactions. And just generally, it is very important to study invasive species in order to develop preventative measures. And here you can see an invasion curve where it shows pretty obviously that the best time to prevent destruction from invasive species is at the very beginning of introduction. The data for this study will be taken from two locations at two different times of the year, in May when fawns are born and in September right before they reach maturity. I hope to be able to identify a trend in the fawn density from May to September. The two locations selected are Hereford, Texas, where there's reported very low hog density, and in Abilene, where hog densities are quite high. The important distinction here is that the deer populations are similar in both locations. The data collected will consist of using game cameras set up at these locations throughout both months that will capture an image at the same time of day at both locations. Once the cameras are collected at the end of the month, I'll go through the photos and identify the amount of fawns seen per day. And the fawns can be easily identified and distinguishable from adults from their spots, which the adults do not have. And here we can see that, very cute. And these are just a couple of pictures that I've taken in the past with game cameras just to illustrate that they are able to capture quality images in which you can distinguish different species or be able to tell a fawn from an adult deer. And they also have time data on them, and you can set them to take a picture at a specific time. So that'll be done at two different locations at the exact same time on the exact same day throughout May and September. So the data intends to test the change in the density of a new generation of local species in order to infer survivorship. Since a new generation of local species will be introduced to a shared and unshared niche between the two locations, a change in survivorship could imply that the cause might be due to differing hog densities. And to test that, I'm going to use a chi-squared test, which is going to determine if there's a significant difference between the change in fawn densities between the two locations. And I could also test a correlation to see if the hogs are a positive influence or a negative influence. Here's just an example of that type of data in which I ended up rejecting the null hypothesis, and there is a significant difference in the change. And here you can see the average fawns per day and how they change from May to September at the different locations. And that's it. Thanks a lot for watching.